Hello to all my young friends who are studying in intermediate and they are watching this video. Welcome to Calculus Made Easy series. We are going to discuss methods of differentiation. So what do we mean by methods of differentiation? We have already talked about certain methods. So let me clarify. See, we have discussed some rules of differentiation. For example, if you have two functions, if we add them or subtract one from the other, or we multiply them, or we divide one by other. So how to find the derivative in those cases? That is sum difference, product or quotient rules, and also for composite functions. However, whatever we have discussed till now, there are certain cases where we can't find the derivative of functions by those rules. So at time the formula we have obtained so far may prove to be difficult in finding the derivatives of some typical functions. So to deal with such situations, some special methods are used, some special methods of differentiation which are listed below. One is differentiation by substitution, the other is logarithmic differentiation. Hope you are aware with the basic properties of log, because we'll be using that. If you are not aware, just go and read the basics of logs. Parametric differentiation, then differentiation of implicit function. I'll explain what is meant by parametric differentiation and what are implicit functions. So we'll discuss them one by one along with one or two examples so that the idea becomes clear in your mind. So first we'll discuss differentiation by substitution. But before we start our topic, we have to recall some important trigonometric formulas. Hope you have read them. If you have not read them, just see them here because we'll be using them. That is the reason. These are certain formulas: sine 2 theta, cos 2 theta, and two forms of cos 2 theta, tan 2 theta, sine 3 theta, cos 3 theta, and tan 3 theta. Just memorize them. We'll be using them here, and also they are used very often. Now, if we have a function f of g, that is f of gx, that means y is equal to f of gx. So f of gx means it's a composite function. Now just read this statement. If we are able to find a function h such that g of hu is f inverse, then substituting x is equal to hu may give derivative of y with respect to x very easily. What do we mean by that? Suppose we have a function h and we substitute x is equal to h of something u, then y becomes f g h u. Now if this portion becomes f inverse, means inverse of this function, then we can very easily find the derivative. It becomes quite easy. I'll just explain you with some examples, but one thing is very much required, that is a condition that f has to be a bijection, because for inverse function we have to have bijection, then only we can have inverse of any function. Now I'll show you what do I mean by this step. Suppose we have y is equal to sine inverse under root 1 minus x squared. Now if you want to differentiate this, you can differentiate by normal methods also, but it will take a couple of steps. However, you can write it like this, say fx is equal to sine inverse x and gx is equal to under root 1 minus x squared. So this function can be written as y is equal to f of gx, because what is f? F is sine inverse, and what is g? G is under root 1 minus x squared. So this is a composite function. Now if we find any function h, say for example here we substitute x by cos theta. So here h is cos function. So then y becomes sine inverse under root 1 minus cos square theta, which is equal to sine inverse 1 minus cos square theta is sine square theta, and it comes out of the under root as sine theta. So this will become theta. That means y is equal to theta. Now dy upon dx is equal to dy upon d theta into d theta upon dx. This is the chain rule. Dy by d theta you can find from here, and d theta by dx you will be able to find from here. So our task becomes quite easy. Now let us proceed with one or two examples. The first example says y is equal to tan inverse 1 minus x upon 1 plus x. So y is equal to tan inverse under root 1 minus x upon 1 plus x. Now if we put x is equal to cos theta, then y will become tan inverse under root 1 minus cos theta upon 1 plus cos theta, which is equal to tan inverse under root, this is 2 sine square theta by 2, and this is 2 cos square theta by 2. So this will become tan inverse under root tan square theta by 2, which is tan inverse tan theta by 2, which is theta by 2. This is your y. So you can now differentiate in two ways. One is you can write it theta is cos inverse x by 2. So dy by dx is equal to 1 upon 2 root 1 minus x square with a minus sign. So this is the answer. The other method is, I'll write it here, dy by dx is equal to dy by d theta into d theta upon dx. Now dy by d theta, you can get it from here. This is equal to half into d theta upon dx. You can get it from here. Dx upon d theta is equal to minus sine theta, and d theta upon dx is minus 1 upon sine theta. So this is minus 1 upon 2. Sine theta is under root 1 minus cos square theta. 1 minus cos theta is your x. 1 minus x square. I hope it's clear to you. Let's take one more example. Y is equal to tan inverse 2x upon 1 minus x square. The only challenge in these problems is what should we substitute here, because you have to substitute such a thing that this becomes tan of something, right? Now here, if you just recall the formula which we had mentioned in the previous slide, put x is equal to tan theta, then y is equal to tan inverse 2 tan theta upon 1 minus tan square theta, which is equal to tan inverse tan 2 theta is equal to 2 theta. So y is equal to 2, theta is tan inverse x. Hence dy upon dx is equal to 2 upon 1 plus x square. Let's see what is the answer. 2 upon 1 plus x square. So I hope that you are clear with this method of substitution. The only challenge in this method is what to substitute. Now, some people may be thinking, okay, that they are not getting ideas as to what they should substitute here. So, my dear friends, those ideas you will only get when you try out good number of problems, so that you are into habit of solving these kind of problems. You will quickly, immediately get the idea. So you have to do lot of practice. The second is logarithmic differentiation. Suppose you have a function y is equal to hx, which is of the form fx to the power gx. So what do we do? Here, if we get some peculiar kind of functions, for example, if you have y is equal to x raised to the power n, here you don't have any problem because this is any real number. But when it's a function, say y is equal to x raised to the power sine x, then you have a problem, because you don't know what is the derivative for this form. For this form, you know n x n minus 1. So what do we do here? We take log on both sides. So hx is equal to fx raised to the power gx. So log hx is equal to gx into log fx. Only thing, this fx has to be positive. That you should ensure it will be given in condition. Now differentiate both sides with respect to x. Now this is a composite function on the left side. First of all, you will differentiate log with respect to hx. So it will be hx here, and then you have to differentiate this one. Now we require to find dy by dx, which is h dash x only. So this is the thing which we require to find. Now here you have on the right side product of this and this one is a composite function. So first you differentiate this g dash x log fx plus gx upon fx into f dash x. So your h dash x, that is dy by dx, is equal to hx into g dash x log fx plus gx upon fx into f dash x. So that is how we write it. You don't require to memorize this formula, you have to just take log. Since I have written it here and it is written in books also, so I thought it is good if I do the derivation. Otherwise, some people may get confused by looking at this. You don't need to remember it. Now, let's take one or two examples. Now, if y is equal to x raised to the power x, and see, we have written here x is greater than 0. That's what I told you. We have to write. So, y is equal to x raised to the power x. So, log y is equal to x log x. Now, differentiate. So, since this is a composite function, applying chain rule, 1 upon y into y dash is equal to derivative of x is 1. So, it becomes log x plus x upon x. For log x, it is 1 upon x, which is 1 plus log x. So, y dash, that is dy by dx, is equal to y into 1 plus log x, which is equal to x raised to the power x, because y is x raised to the power x, 1 plus log x. So our dy by dx is equal to this. I hope you are clear with this logarithmic differentiation. So this is the answer. Let's go to the third one, parametric differentiation. If we write x is equal to function of t and y is also a function of t, x is equal to ft and y is equal to gt. Here t is called a parameter. X is related to t and y is also related to t. We have written them separately. We have not shown a direct relation between x and y. So this is called parametric form. So let me give some interesting example. Don't connect it mathematically. Suppose you have a and x is the son of a and y is the daughter of a. So x is related to a, y is also related to a. So we are only writing that x is the son of a, y is daughter of a. However, you can make out that x and y are brother and sister. Something like parametric form. Although please don't connect it mathematically, that's just an interesting example so that you remember. Now in this case, dy upon dx, if we have to find dy upon dx, it is equal to g dash t upon f dash t. How do we get this? See, y is equal to gt, and g, now t substitute from here is f inverse x. So now y is equal to g of f inverse x. Now dy upon dx is equal to, now since this is a composite function, you have to differentiate g with respect to f inverse x. So this is g dash of, what is f inverse x? Is t into, then you have to differentiate f inverse x with respect to x. Now this will be g dash t, and this will be, since f inverse x is equal to t with respect to x. So this is dg upon dt, and this is dt upon dx. So you can write dg upon dt upon dx upon dt. Now what is x? X is ft. Dg upon dt and df upon dt, which is equal to g dash t upon f dash t. So that's how we get this formula. Hope you are clear with this. Now let's try out one or two examples. Now, x is equal to a cos cube t, y is equal to a sin cube t. We have to find dy by dx. So dy by dx is equal to dy by dt upon dx upon dt. Now here dx upon dt is equal to 3a cos square t, and cos t, when we differentiate, it becomes minus sin t, and dy upon dt is equal to 3a sin square t, and then when we differentiate it, sin, it becomes cos t. So here it becomes dy upon dt is 3a sin square t cos t upon minus 3a cos square t sin t. This will get cancelled, this will get cancelled, and so this is minus tan t. Now let's check the answer. It is minus tan t. Hope you are clear with this. Let's take one more example. Here fx is equal to x raised to the power sine inverse x, and gx is sine inverse x. Find the derivative of fx with respect to gx, that is df upon dg. Now just now we told how to find dy upon dx. If y is related to t and x is related to t, what you did? You did dy upon dt upon dx upon dt. So what you need to do here is df upon, here you don't have t, df upon dx upon dg upon dx. That is, what is df upon dx? You know, f dash x upon g dash x.